Propositional resolution works only on expressions in clausal form. Before propositional resolution can be applied, our premises and conclusions must be converted to this form. Fortunately, as we shall see, there's a simple procedure for making this conversion. A literal is either an atomic sentence or a negation of an atomic sentence. For example, if P is a logical constant, the sentences shown here are all literals. A clausal sentence is either a literal or a disjunction of literals. And a clause is a finite set of literals, interpreted as a disjunction. The set can contain one element, two elements, or more elements. Note that the empty set is also a clause. It's equivalent to an empty disjunction, and therefore is unsatisfiable. Why is that? Well, remember that a clause is a disjunction. The more disjuncts we have in a clause, the easier it is to satisfy. The fewer disjuncts, the harder it is to satisfy. In the limit, when there are no disjuncts, we have an unsatisfiable clause. As we shall see, the empty clause is a particularly important special case in resolution. As mentioned earlier, there's a simple procedure for converting an arbitrary set of propositional logic sentences to an equivalent set of clauses. The conversion rules are summarized here. All of the rules within each group should be applied repeatedly until there are no changes before moving on to rules in the next group. The purpose of the transformations in the implications out group is to eliminate all implications and biconditionals. We rewrite phi 1 implies phi 2 as not phi 1 or phi 2. And we rewrite a biconditional as a conjunction of two transformed implications. The purpose of the transformations in the negations in group is to move negations through other operators until they are applied directly to proposition constants. We drop double negations. We push nots through ands by negating the conjuncts and changing to ors. And we push nots through ors by negating the disjuncts and changing to ands. The purpose of the distribution rules is to push or operators to the inside of and operators, and to normalize every disjunction of disjuncts to a single disjunction, and every conjunction of conjunctions to a single conjunction. The purpose of the final step, operators out, is to turn disjunctions into clauses and to turn conjunctions of clauses into separate clauses. As an example, consider the job of converting the sentence G and R implies F to clausal form. The conversion process is shown here. In the I step, we eliminate the implication operator. The N step, in this case, has no effect. Same for the D step. In the O step, we change each of the conjuncts to a clause. As a slightly more complicated example, consider the following conversion. We start with the same sentence, except that in this case it's negated. The I step in this case is the same as before. However, this time around we have a negation operator on the outside, and we need to push that in before we can continue. First, we distribute the negation over the conjunction. Then we distribute the negation over the disjunction in the second conjunct. And then we remove the double negative. In the D step, we distribute the OR operator over the AND. And finally, in the O step, we convert the two conjuncts to clauses. In this case, we end up with two clauses, each with two literals. Note that even though the sentences in these two examples are similar to start with, disagreeing on just that one negation operator, results are quite different. This exercise tests your ability to convert propositional logic sentences to clausal form.